This YouTube is continuing on my journey towards getting the HFJ350M antenna on the road with my KX3. I need to make some radials for it. And in order to do that, I wanted to check what I actually needed in the way of radials, and what effects having one radial would be over having two, and if there's anything to do with like elevating the radials, if that changes anything. So I have this wire here, which I have actually made radials from. It's 1mm conductor with a 0.5mm insulation. It's a little bit kind of neoprene-y feel, silicone feel. It's actually quite nice, and I've modelled it in eznec. So let's tuck myself away and open eznec to show you the two things that I've found. I think the Americans call this easy neck. Okay, so let's open up KX3 with a vertical and a radial tested on the ground. So that's our first example. I've already put all the information in, and this is basically what it looks like. Just kind of rotating it. This is looking from above, so going north on the ground we have a radial, and we have the vertical element. I wasn't quite sure how to model the antenna because the actual antenna is only short, but I figured if we just put the quarter wave vertical in, and quarter wave radial, that would be resonant. So that's what I've done. Here's a look at the measurement of the wires. So we've said we have a vertical of about 5.1 metres, and we're saying it's about 5mm wide, so it's a telescopic antenna. And the radial on the ground, 5.36 metres, 0.5mm diameter. We said that was 1 mil, and insulation of 0.5 mil. So let's check out the SWR of that on 20. So we're saying 13.6 meg through to 14.8. There we go. And so it's resonant down there, 14.1, 14.2, where we want it to be. And you can see it goes out to here, so 14 megs through till 14.3 megs, less than 1.5 to 1. So that's good. Let's look at the pattern, the far field plots. So this is the thing that I found interesting. Okay, this is looking from above, straight down. It's reasonably omnidirectional. Now, if we rotate that around, you can see that there's slightly more in the north direction there, and it's higher up. So it's not a cloud burner, but there's very definitely a difference between omnidirectional and that. Let's have a look, 2D. So that's two-dimensional of what we're looking at there. It makes it just a little bit easier to look at. And looking from above, you can see that the pattern is slightly more north. It's reasonably omni, but it's more north than it is south. Okay. So that was that. Let's now show you what I ended up with and the reasoning why. So this one here, KX3, 20 metre vertical, 2 radials test, that's just what I call it, 2 radial test, table to ground. So that's a KX3 on a picnic table, a small drop away from the antenna to the ground, and then across on the ground. So here's the wires for that, and here's what the antenna actually looks like. So you have the vertical, the picnic table, just roughly simulated, goes down to ground away from the table a little bit and then across the floor. That's quite straightforward. So let's check out the SWR of that. So in actual fact, a better SWR, we could put more increments in to get a smoother curve. In fact, yeah, let's do that. Yeah, there's a better idea of what we've got. So we can see 13.85 through to 14.5. That's going to be less than 1.5 to 1. So that's going to be absolutely perfect for what we want. 14.1 there, 14.150 there is close to the resonant point of it. 14.2 all the way out here to 14.3. So that is totally usable on 20. But what we're really interested in was the pattern there of the antenna, the far field plot. So this time, have a look at this. That I would say, there's north, that's looking straight down north-south. That is omni, and it's quite a low radiation angle there. That, if you remember the other one, it lifted somewhat there. So let's have a look in 2D. There we go, totally omnidirectional. And it's quite low down what we got, that's 5 degrees down there, so yeah, that's pretty good. That will do me, and for the sake of putting an extra wire down in an opposite direction, that's worth doing. So it's not essential that you put that second wire down, but putting it down certainly makes that more omnidirectional than the first example. So that's what I went with. So the measurements here, what were they, 0. Oh, okay, we can actually look at the antenna to determine what we need. So let's do that. View the antenna, and if we, well, you can see the actual waveform superimposed on it. If I hold the mouse over, it will tell me that that's 76.5 centimetres long, and that is 3.8 metres long. So the combination of those two, 76.5 and 3.8 metres, is 4.56 metres. So that's what I cut my good old orange cable out. I've got 4.56 going each way. And it goes into, there we go, it goes into an Anderson PowerPole connector because I want this interchangeable. I want to make another set of these for 17 metres, and on the antenna, originally on the antenna I placed a rigid piece of wire between the ring crimp there and the crimp pin inside here, but I figured that was quite, that was in the way, shall we say, for packing, not flexible, and it could cause some damage or get damage caused to it. So I replaced that with a piece of actually earth cable out of twin and earth. So that's now flexible, and you can plug the radials on the other Anderson PowerPole, just click it straight in, and it's interchangeable. And it's only about 2 centimetres there, so in the scheme of things that's not really going to be noticeable. We may have to tune up or extend or shorten the radials slightly, because eznec's maybe not perfect with our particular ground, I don't know. But that's the experiment we will do. Hope you enjoyed the short YouTube.
So this video, if you like it, our video, comment down below a thumbs up.
Thanks for watching VA3SII. Bye.